Welcome to Data Viz with Class. I'm Caleb Class. Today we are going to answer the classic question, is running bad for your knees? I saw a family last week and there's always somebody saying, you gotta stop running, it's killing your knees. I looked on YouTube, found plenty of videos saying that running is not bad for your knees, and they explain why physiologically. I want to approach this from a data perspective. So I'm gonna start my watch, suck down an energy gel, and we're gonna figure this out together. So I found a huge data set on osteoarthritis that would be perfect for this analysis, but contains patient data. You have to request permission from the government to use it. We're not going to use that one. So I found this study from 2023, published in the Journal of Orthopedic Sports Medicine. They looked for all the previous studies they could that compared runners and non-runners to see if one group had more knee issues than the other, and they put them all together. They looked at knee pain and osteoarthritis, which is one of the main joint disorders that affects older people. For this video, I just want to focus on knee pain because the data is simpler. I just want to ask, do runners or non-runners have more knee pain? So if we look at table 3, we see 5 studies that look at the percentage of runners with knee pain, 4 studies that look at non-runners, and then they add up all the data and try to combine it together. Some statisticians might disagree with this method, because some studies might look at older people, which have a higher percentage of knee pain, while other studies might have overall participants which have higher percentages of knee pain for some other reason. So if you just add up the counts, you're not necessarily considering those factors. So what we're going to do is we're going to calculate an odds ratio within each study as well as a variance, and that's going to say, do runners have higher or lower amounts of knee pain than non-runners? We are then going to use a meta-analysis method that combines the odds ratio to give us an overall estimate. We're going to make what's called a forest plot to do this. I've never made one of these before, so we're going to figure it out together. If you want great detail on how to do this sort of meta-analysis, there's lots of other videos that explain this meta-analysis method in great detail, as well as a resource I will post in the episode description. I'm just going to figure this out along the way. If I mess up, let me know in the comments. If you want to join me, check the link to the data in the episode description. Let's load it in. Let's start by loading in the tidyverse and our data set. As you can see, it is very simple. We see the total number of runners in each of the 5 studies, how many of them had knee pain. We see the same data for non-runners and how many of them have knee pain. And we have a p-value comparing the 2 groups. Does one group have more or less knee pain? We also see that one study included only runners and no non-runners, so I'm going to remove this for this analysis because we need odds ratios for each study. Okay, so what I needed to do was convert the non-runners columns into number columns because they read in as character columns. Then I could remove the ones without a number there. Okay, so now we have 4 studies that have the number of runners and the non-runners, how many have pain. Now I'm going to more or less follow this tutorial on meta-analysis of ecological data, but it's good for a lot of other meta-analysis as well. So what we need to combine these 4 studies, we need to calculate an odds ratio, we need to calculate a variance for each study. So when we have this 2x2 table, how many runners with pain without pain, how many non-runners with pain without pain, you can see the formula is n11 times n22 divided by n12 times n21. Okay, that's confusing, that doesn't make any sense at all. What that really is what are the odds that a runner has pain divided by what are the odds that non-runners have pain. A little bit different from a percentage, but it's kind of the same idea. So if the odds ratio is high, that means runners have more pain. If the odds ratio is low, that means non-runners have more pain. We're also going to calculate a variance, and that is kind of the precision of our estimate. So the more people you test, the more precise your fractions are, or the more precise your percentages are. So if we only ask 2 people, one of them has knee pain, that's 50%, but we really have no idea what the real percentage is because we only asked 2 people. If you ask 1,000 people, you're much more precise. So let's just add those 2 columns real quick. Okay, so we are calculating odds ratio and variance for each study, And what these say, when I say non-runners minus non-runners pain, the total non-runners minus the total non-runners with pain, so that calculates the non-runners without pain. And the same for runners minus runners with pain. So we've got runners with pain, runners without pain, non-runners with pain, not runners without pain. We can use that as the 4 numbers to calculate our odds ratios and our variances. So we can look at the results and we can see that in 3 of the studies, the odds ratios were lower. That means runners had less pain. In 1 study, the runners had more pain. The variance depends on how many participants there were in each study. So the lowest variance had the most participants. That's our most accurate or precise measurement. Say the most precise measurement. The other 3 had pretty similar variances, 0.04 to 0.09. So those studies didn't have quite as many participants, so a little less precise. So now what we're going to do is combine these odds ratios and variances using the metafor library, and we are going to figure out an overall odds ratio, variance, and a p-value. And the p-value, an estimate of our confidence that there is some difference between the amount of knee pain experienced by runners and non-runners. So for our meta-analysis, I'm following this tutorial. We need to load in the metafor library. If you need to install it, you can use install packages. And we are going to do what's called a random effects model. Again, if you want to read about it in this book, other resources, other YouTube videos, but basically the idea is just that the studies aren't the same thing. They're not studying the same people. There could be different effects in each study. Okay, but we want to calculate an overall estimate across those 4 studies. Do runners and non-runners have different amounts of knee pain? This one has statistics in it, and I'm not a statistics. All right, so this is why you should learn statistics, because then you will understand how to do these things. And I have just looked online for 3 hours, and I think I figured it out, but I'm still not 100% sure, so you can let me know if I messed up. So we use the RMA function to figure out a random effects model that combines our different odds ratios, but they need to be log odds. Pretty sure they need to be natural log, and this is how we do it in R. We need our variance from each study, and then this last bit, we are just saying this is the name of each study. That's going to help with our graph, and then finally, what's our data frame? And if we look, we see model results. Overall, a negative log estimate that says runners have less chance of knee pain, but the p-value is pretty high, 0.3. That means it's not significantly different. So we cannot say that one group has more or less knee pain, but we can say that at least it doesn't look like runners get more knee pain. So that's nice. So now we just need a few more things to make that actual forest plot to combine all the data together. I'm going to copy and paste from this tutorial. All right, so first we have the plot that puts the data for each study. Then we are adding our little summary diamond that's saying what is the odds ratio across the studies. Let's see if it works. Ooh, that's a good start. All right, 1 for 2. Fix the typo. I think we just need to run it all together. So let's just look at what we have so far. What we can see is for each of the 4 studies, we have the odds ratio. It is sized by how many participants there were. It also gives us that variance estimate. And so we know that our biggest study also has the biggest difference between the 2 groups. Instead of odds ratio, let's go ahead and let's change to odds ratio instead of response ratio. Okay, so log odds ratio is negative. That means runners have less chance of knee pain. All the other ones, the variance, the uncertainty range, the confidence interval. All the other ones, the confidence interval overlaps with 0. So that means there's not a significant difference between the two groups. So these two, they're a little bit lower. This one, the runners have a little more knee pain, but it's not significantly different. So when we put it all together, it kind of makes sense that overall, it's not significantly different between the two groups. Now I should be able to figure out how to get that little dang orange diamond on this graph. So I'm going to take 10 more minutes and see if I can figure this out, because it'd be nice. So one thing I want to do, I don't know if this actually is a ggplot object, because it looks pretty different. Let's see if we can add a theme to it. Yeah, it doesn't like that. So I think this is a separate type of plot. So we're not going to be able to do that. So finally, how do we get this poly into it? Can we figure it out? I think we've been somewhat successful so far. This is the final push. Can we do it? Let's look back at our tutorial to see if I missed something. All right, I give up. So what did we do? We have our 4 lines representing our 4 studies. We see that one is significantly lower knee pain for runners. The others, we cannot conclusively say one group or more has more knee pain. Overall, there should be a little diamond that overlaps with our 0 line, our no difference line. So that we'll add in post. And that will tell us that overall we cannot conclusively say, and overall that'll tell us that we can't conclusively, and overall that'll tell us that we cannot conclusively say that one group or another has more knee pain. If I can figure out how to add that little diamond in I will post that in the episode description. If one of you know how to do it, post it in the comments. So overall, we looked at the data. We see one study where runners have much less knee pain, but overall, we can't say for sure. I'm okay with that. I'll keep running. We also look at osteoarthritis, a more serious outcome. So osteoarthritis, if you have that in your knee, you're probably on track for a knee replacement, which is no fun. So the authors of this meta-analysis that I used today also looked at a bunch of studies where they compare osteoarthritis between runners and non-runners. And in those studies, they see that maybe runners have a few more bone spurs in their knees, but overall the osteoarthritis rates are not really different. Maybe even a tiny bit lower in runners, but not statistically significant. So we can't really say that they're different. So what did we do today? We figured out how to do something new. We didn't do it all the way, but we figured it out enough. We did a good job. We grew a little bit. We learned something. I think that's great. We're going to keep learning after this. We're going to figure out how to do it better. As far as knee pain and running and knee health, what I would say, look at those other videos. I think they're useful. One thing that we do know is that the cartilage in your knee, it actually doesn't get nutrients unless you move your legs, or you're bending your knee, you're unbending, you're walking, you're running, you're doing whatever. You're sitting at your desk, you're kicking your knee, or you're kicking your legs out, you're bending your knee, you are getting more nutrients to your knee, you're preventing some issues with your knees in the future. That is why if you are driving for 3 hours, you get out of the car, your knees feel real bad. They have not gotten nutrients for a while. You need to get out of the car, you need to stretch them out. They're gonna feel better. So overall, physiologically, we're pretty sure that running is good for your knees, walking is good for your knees, any sort of movement, getting out there, exercising is good for your knees. Get out there, let's exercise. However, running with bad form is bad for your knees. There are plenty of other videos about running with good form. I suggest taking a look if you are a runner, making sure that you are running with good form. If you've got a running coach or someone who can just watch you a little bit, make sure your knees are kind of staying in, but not too much in, and your feet are striking correctly and all that stuff. That can also help you with your knee health. So I think that's enough for today. I'd kind of like to get in there with ggplot and make the graph look a little bit nicer, but we learned something new. We made a nice graph. We learned about knees using that graph. So I think that's enough for today. If you know how to send this graph into ggplot or to add that little diamond or any of these other things that we could do to make this graph better, feel free to let me know in the comments. I'd be happy to revisit this in the future. Hey, it's me again. So it's about 3 weeks later and I haven't been able to sleep because I did a bad job with this one, but we are going to fix it and it's going to be really easy. So we loaded in our data, we set up our odds ratios, we did a completely reasonable analysis, but I am going to note that you really should know some statistics to be doing meta-analysis. So I will post some intro links in the episode description. Okay, and then what we tried to do is put all this whole mess together to make a forest plot, running this add poly thing to add the overall summary polygon, and it didn't work for us. So one nice thing you can do, you can click, and if you hold shift, click somewhere else, it highlights the whole range. Okay, so we can run all this again with Control Enter, Command Enter on a Mac, and you see we wanted that frequency polygon, but we didn't get it. So we did all this work, we did not get what we wanted, and it turns out all you need to do is take this model result. So we ran this RMA function to and it did a meta-analysis for us, and we saved it, and it's completely reasonable. And all we need to do is take model results and put that straight into forest. It ran meta-analysis for us, so all we need to do is take this model results and put it straight into the forest function. So we didn't need all that extra stuff that I tried to enter for you. All we need to do is put the model results into forest. It gives us the study names, the range for each one. So this second study happened to be the biggest one. It gives us the results for each individual study. And most importantly, it gives us this nice polygon for the random effects model, which summarizes the 4 studies. And what this polygon says, it overlaps with 0. So that's going to say we are not sure that running causes an increase or a decrease in knee pain. It leans more to the negative side. The negative means that people who run tend to have less knee pain than people who don't run, but the result's not statistically significant. Our actual confidence interval is pretty wide, so that means there's a lot of uncertainty here, but the good thing is there's not clear evidence that running does cause knee pain, which would be sad. So let's go back, let's do that formatting stuff again. Right, so all you needed to do before is model results into the forest function. Now we can do our formatting, right? We can set our XLab, we can set text sizes, bar sizes, we can even change the color of the polygon. And there we go. We've got our 4 studies, we've got the statistics for each study, and then we made our polygon orange, and we can see that the random effects model overlaps with 0, although overall it tends to be a little negative, which is good for the runners. Not too hard. Big lesson from this, it's good to do your homework or your project or whatever you have to do. Good to do it ahead of time, not have to get it done in an hour because maybe you're not thinking straight. If you do it ahead of time, you can sleep. The next day, maybe you do a better job.